check if there's a difference between these two groups, then you can use the Mann-Whitney U-test. Now you're right if you say that the t-test for independent samples does the same thing, because it also checks if there's a difference between two independent groups. The Mann-Whitney U-test is the non-parametric counterpart of the t-test for independent samples. However, there's an important difference between these two tests. The independent samples test checks if there is a mean difference. So we have our two groups, we calculate the mean of both groups and check if this mean differs. On the other hand, by using Mann-Whitney U-test, we check if there is a rank sum difference. What exactly does that mean? When we have our two groups, we check if there is a difference in the rank sum of the first group and the second group. How do we calculate the rank sum? In order to do this, we assign the rank to each participant in a group. So we sort all participants from the smallest to the largest value. For example, this person has the smallest value, this person the second smallest value, that person the third smallest value, this person has the fourth smallest value, and so on and so forth. Now we have assigned the rank to each person. Then we can simply add up the ranks from the first group and add up the ranks from the second group and compare the ranks. In this case, we get a rank sum of 42, and in that case, we get a rank sum of 36. But don't worry now, we'll go through this in more detail in a moment. The big advantage now is that if you don't look at the mean differences, but at the rank sum, the data doesn't have to be normally distributed. When using the Mann-Whitney U-test, the data doesn't have to satisfy any distribution form, and therefore it doesn't have to be normally distributed. In the t-test, however, the data must be normally distributed, which is the necessary scale level now for the Mann-Whitney U-test. First, you need a nominal or ordinal variable with two categories. For example, gender with male and female. Or another example, if I want to test a drug, I have one group which gets the drug and another group which gets a placebo. Or if I have a production plant, I want to compare the production of plant A and plant B. These are all nominal or ordinal variables with two categories. Further, we need another metric or ordinal variable as the dependent variable. Because of the fact that we form rank sums, there must be naturally a rank order. Here we could take, for example, salary, well-being, or weight. So in short, for the Mann-Whitney U-test, we need a nominal or ordinal variable with two categories and a metric or ordinal variable. But what are the requirements now for the Mann-Whitney U-test? The requirements are: first, we need two independent random samples with at least ordinal scale characteristics. Further, the variables do not have to satisfy any distribution curve. So on the one hand, we need two independent random samples that have at least ordinal scaled characteristics, and the good thing is that in this case the variables do not have to meet a distribution curve. Therefore, whenever a normal distribution is not given, we cannot calculate the t-test, and therefore we use the Mann-Whitney U-test instead. Let's now come to the hypotheses. The null hypothesis is: in a population, the sum of ranks in the two groups does not differ. So in a population there's no difference, and the difference is determined by the fact that the sum of rank is the same. The alternative hypothesis is: in a population, the sum of ranks is different between the two groups. Therefore, the null hypothesis is: there is no group difference, and the alternative hypothesis is: there is a group difference. So let's take a closer look at the question now, what rank sum means. Let's look at an example. Let's assume you have measured the reaction time of a small group of men and women, and you want to know if there is a difference between these two groups or not. In order to do this, you add the values in a table. On one side you have gender with female and male, and on the other side you have the values for reaction time. Unfortunately, this data is not normally distributed, so we can't use a t-test, and therefore we now calculate the man-Whitney U-test. How do we do this now? First, we assign a rank to each value, so we look at the smallest value. The smallest value is 33. That gets rank 1. Then we look at the second smallest value, that is 34. This value gets rank 2. Then we look at the third rank, that is 35, which gets rank 3. And now we go through that for all 4, 5, and so on and so forth. Finally, we have assigned a rank to each value. 45 is the largest value, therefore it gets rank 11. Now we have defined all the ranks, and we can just add up all the ranks of women and all the ranks of men. The rank sum is abbreviated with T, and we get T1 for women with 2 plus 4 plus 7 plus 9 plus 10 plus 5, which gives 37. We can do the same for the male group now. Here we get 11 plus 1 plus 3 plus 6 plus 8, which makes 29. Again, our null hypothesis is that both rank sums are equal. The alternative hypothesis is that the two rank sums are not equal. Now we want to calculate the p-value, so let's move on. So what we now did is we calculated the rank sum for the female participants, and we have the number of 6 cases. Therefore, we have 6 female subjects. We can now calculate the U1, so the U for the female participants, using this formula. Here we have N1 and N2, so the number of cases of female and male plus the rank sum of the female participants. If we insert our values, we get a U1 of 40. Now we do exactly the same for male participants. For male participants, we have a number of 5 and a rank sum of 29. Here we can calculate U2 with the same formula. The only difference is that we have N2 instead of N1, and of course we also have T2. In our case, the result is 16. So now we have calculated U1 and U2. The U for the man-Whitney U-test is now given by the smaller value of the two. So in our cases, we choose between 14 and 16, which is of course 14. Further, we need to calculate the expected value of U. And in our case, we get 6 times 5 divided by 2, and this equals 15. Last but not least, we need the standard error of U. The standard error can be calculated with this formula, and in our case, we get the result 5.4772. If we take all these values now, we can calculate Z. The Z value results from U minus mu of U divided by the standard error. In our case, we get 14 minus 15 divided by 5.4772, which makes 0.1825. So now we have calculated the Z value, and with the Z value we can further calculate the P value. Our Z is minus 0.1825, and we can now use this value in order to calculate the corresponding p-value. Depending on how large the sample is, the p-value for the man-Whitney U-test is calculated in different ways. For up to 25 cases, the exact values are used. These values can be read from a table The normal distribution can be used as an approximation. So in our case, we would use the exact values, but for this example, we use the normal distribution instead. In order to do this, we can simply go to datatab.net or use any other calculator that calculates the p-value for a given z-value. We now only need to enter the z-value of minus 0.1825 and then we get the p-value of 0.855.